Hello, team. Okay, we were building a simple website. I was thrown off for a moment because I had moved the value to the central database here. But as I said before, the body value is special because it's generated as a result of every model, basically. So I have to use another name. So I'll move the name of the value back to body in the model. And then I'll call it just text in the database. And then I have to change it in the template.
Okay.
Yeah. So instead of the body value, which is special, I'm now using the normal value text, which we have made up ourselves, and it has no special value within no special meaning within the system. So if I build the site again now, go to the stage. Oh, I'm in the wrong filer again. This is the one. The stage directory of our demo site. See, now we have the Dutch text, because now everything is consistent with the text value, but the text value is now coming not from the model but from the central database. So it's really the structure of the content management system is so that you are free to decide where you want to put the data. You can put it straight in a template, or you can separate it so that you split the content and the presentation, and then you can either put it in a model that corresponds to the website structure, or you can put it in a central database with a different organization. It's probably not entirely easy to see the consequences of that by this simple example, but this is really extremely useful in all the websites that we build.
But Kai, when you put in the data text, when you put there the page frame, then that frame is the most important as far as I can understand.
Yeah, but frames is a name of your own, and it does have a special meaning like body, but in a very different place. And the point is, what I wasn't expecting was that a model always generates a body. So you can't propagate the body value through a model, because the task of a model is to generate a body.
Yeah.
And so that didn't work. So you have to use a neutral value. And the frames value is different. It's also special, but it's used in a different place to.
But generally speaking, the model value is more important than the data.
It has priority. What you just saw is that the model has priority over the data.
Yeah.
Okay, now we have an extremely simple website, and now we want to upload it to the server. And to do that, I'm going to copy the account example from the example site, and here is where the central database comes into use, because if you have a username and password for a site, it's not supposed to go into the website. It's supposed to be maintained in the central database. So that's the data directory. Now here's the example site. And the user account for FTP uploading is in the FTP folder, so I'm going to copy the FTP folder from the example site to the demo site, so that you can see what the smallest site is that you can use to build a site and to upload a site. So for uploading we need to add this FTP account information. And in this case it's split into two files. And we have to set the parameters. It's all text files in the same format. This is set at a host that we used to host a number of our websites. But now we have to change this to the local server. So again, it needs to be the IP address. And the username we made was demo. And the static field is the location where the site is uploaded within your home directory on the server. And we made a website folder for that. So this is the location on the server. And passive says that it's being uploaded with passive FTP because the default active FTP sometimes doesn't work. If you have a firewall in between or something. Now then the password, which is secret of course, but our real password was demo. So I can build the site, and let's now see if I can publish it. That was the other important command.
With the spatie.
Oh no. Let's see what it does. It gives the account information that it constructs. So what it's really trying now is this URL, an FTP URL at this user and this password to this server in this location, and the only thing it needs to upload is the front page that we've made. And it takes a while again, but this last line is the file that it is working on, and it's only one file, so it says it has done it. Now we should be able to see that because we still have a web browser open to the server, and when we started we got a not found message from the Cheyenne web server. So let's see what happens if I refresh this page. Oh, there's our website. Let's sync that in for a moment, because this basically concludes today's demonstration. But there are interesting things to tell about what has really happened, and there are other interesting things that I can show. For example, this is a very simple example, of course. But if you have a look at what websites you can make with this, I have copied a documentation website on the hard disk that I've made the past few weeks in the demo folder. This is our new REBOL website, and I've published 2 extensions for REBOL 3 there in the past few months, and I've written documentation for it. And this is a copy of the website build system. So this is a real life version of the example that we just made. So again, we have to go to the stage directory for the build site. And so you notice that a complete website is built as static local files, basically this way. So you have all the files of the website on your hard disk, and if you're a bit careful with the links that you construct, if you use relative HTML links, then you can also show the same HTML files from the local hard disk. So especially for a documentation website like this, it's very useful because you can generate static documentation files. So this is the index front page again. So if we start that in the Webster web browser, this time it just runs from the hard disk like we have done the entire example. But this is a copy of a website that is really running on the internet. So this is the front page. It already has a number of HTML elements. This is a table with 2 columns and a few logos, and the page has a footer with some of our logos. Ja, klopt. This is a Windows type icon, a .ico file.
Oh.
And it seems that our Webster browser doesn't understand it. So somehow Webster doesn't draw a Windows .ico icon. So we'll have to look into that. And the other icons are a PNG and some GIFs. So there are 2 REBOL extensions that I've made and published in the past 2 months.
And on the right side you're also...
Yeah, but this is because this is a screenshot, and this is on a link to the Syllable websites. So the screenshots are not in this site. So that's why the screenshot is missing. There are 2 extensions, and extensions are new in REBOL 3. In REBOL 3 you can make extensions, and an extension that is a module that is written in a different language than REBOL. So the main usage for that is if you want to use C programs from REBOL. Many C programs, especially in operating systems, are around, and there's a lot of functionality in there that you often want, and you can also use C extensions to make some parts of a program faster than REBOL can do, because REBOL is an interpreted language. So again, like we just made a Hello World website example, I've made a Hello World example REBOL extension so that you can see how to program it. Oh yeah, see, it takes a while to show it. That's because it's looking for the screenshot on the Syllable site. So it'll have to wait for a timeout again to go to the Hello World example.
Doesn't react on escape?
No, it'll have to wait for the timeout. I hope it understands it, because on this local network there is no DNS server, so it can't even resolve the host names. So it's trying to do that all the time. No, it takes a bit long. Well, we can go back to it later and look for something else, because the other interesting thing is that the second example, the first one is the Hello World example, so that other people can see how to write REBOL extensions. The other extension is for the cURL networking library, and curl is a library that can do many of the things that we have done today in the command line. It can do FTP, and it can do SSH, scopy through SSH, and it can do web accesses. It's actually our Webster web browser. One of the libraries it's using is curl. So curl is the main networking library in Syllable. And that's true both in Syllable Desktop and Syllable Server.
So when I go to a website, for example new.nl, then when I give the command to open the website, it says to curl fetch me new.nl.
The HTTP communication is done through curl, and the cookie handling is done through curl. So it's really a very capable library. It's not a simple library for just downloading or uploading a file. It can do all sorts of elementary operations. So you can really use it as a base to build a web browser on. And that's what we've done with the Webster browser.
Because I saw the log files, and I saw many post and gets, HTTP post and get commands, and those are given by curl.
They're executed by curl.
Yeah.
They're commanded by Webster and then executed by the curl library. And that should be mostly get commands, sometimes a post. We've just done something similar by uploading the website from Syllable Desktop to Syllable Server. We've done that through FTP. And REBOL is a very network-oriented language. It's a messaging language. And the idea is to do messaging over networks. So REBOL has a lot of network protocols built in, but that was the case for REBOL 2. And REBOL 3 is not complete yet, so REBOL 3 is still lacking many of those network protocols. And one of the things that's lacking is an FTP protocol. So we've been using the content management system with REBOL 2, so we could do FTP uploading simply within REBOL. But now, when the CMS is ported to REBOL 3, a few things are missing, and one of them is our FTP upload. Well, I wanted to have a binding between REBOL and the curl library anyway, because curl is the main networking library in Syllable, and we've had REBOL 3 on Syllable for a year now, but now the big next task is to do integration, to integrate them well. Otherwise it's just a language on an operating system. We need to do integration to make it really worthwhile. So I wanted to have this binding from REBOL to curl, and that does integration between REBOL and Syllable. So it solves a problem for Syllable, because we now have a very powerful standard scripting language on Syllable. But it also solves a problem for REBOL, because REBOL 3 doesn't have those network protocols yet. So by writing this binding, I get integration between Syllable and REBOL, and I get missing network protocols in REBOL 3. And one of those protocols is FTP. So I've extended the content management system to do upload through the curl binding in REBOL. I believe the browser is really hanging on finding that image. So I could try to start another one. I'll clean up a bit. Let's try to open it directly. Here's my curl binding. You can see here's a binary library, an SO, a shared object file. So that's the download on our website for the binding. And the very interesting thing is that this is one binary that works on Linux and on Syllable Desktop. And that's weird because it's not supposed to work. But it was already the case that the way that REBOL 3 runs on Syllable Desktop, it's not fully ported. The library, REBOL 3 is split between a library and a front end. And we are recompiling the host environment, the front end, on Syllable. But the library that we're loading is simply the Linux binary library. And in normal cases, this never works between operating systems. Or you have to do humongous extra environments to make it work, such as the Linux compatibility on FreeBSD. If you want to run Linux binaries on FreeBSD, you have to install a complete set of Linux libraries on FreeBSD. But we're not even doing that. I'm using the Linux library that contains the REBOL 3 language interpreter, and we're just running that straight on our own Syllable system libraries, mostly the C library, the GNU C library. And we can do that because we're using the same C library as Linux, as most Linux distributions, the GNU C library. And that library is ported to Syllable, and the interface, the portability interface, is at the C library level. So if a Linux library is reasonably simple, we can run it unchanged, the Linux binary, on Syllable without any compatibility environment such as you need on FreeBSD, for example. You have to know a little about operating systems to fully see what that means, but this is very exceptional.
It's like putting a Mercedes-Benz motor into a Fiat Panda and without any work it just runs.
Or the other way around.
Yeah.
And the same goes for this binding. This is the binding, the REBOL 3 binding. It's written in C. And it binds the REBOL 3 interpreter to the curl network library. And I have compiled this on Syllable Server. And it works unmodified on Syllable Desktop the same way. So this library is a Linux library and it just works. Well, this is the Windows version that someone made for me. The DLL, the Dynamic Link Library, and this is the thing about Windows, it doesn't have all those open source libraries. So if you want to get this running on Windows, you have to install all those extra libraries that curl interfaces to. Because curl is also a layer, and it interfaces to many other open source libraries. And you only have to interface to the curl interface to get all that functionality. But in Syllable it's included, and in Linux it's included. And on BSD it's included, but on Windows you have to install all those libraries yourself because they're not in there. So these are the two distribution packages for Windows that someone made for us. And this is the Linux binary that also works on Syllable Desktop. And now we'll see if I can start the documentation straight from here. Yeah, starting straight works better. Again, there was a screenshot here, but it's missing because it's on the Syllable website. And there were logos here. They should have been here. So apparently oh yeah, I know. I'm using a path here that doesn't work locally, and that's actually an imperfection in the content management system. So there are also a few logos missing here. But this is the documentation that I wrote for the cURL-binding. And this is written in the content management system that I just demonstrated. So this is what you can produce with the content management system. You can produce websites, and you can produce documentation. So it tells you how to install the thing, and how to use it, preferably on Syllable, of course, and if you really want on Windows, then you have to install all that extra stuff. But now we get to the program examples. And that's another thing I wanted to show, because this conference is really where we're introducing the cURL-binding. It's been, the REBOL community knows about it, but we haven't really published it yet. It's on the website, but next week I'm going to announce it widely on OS News. So this conference is where we're introducing this cURL-binding. This is the first binding from REBOL to Syllable, basically, because cURL has been selected as the main networking library for Syllable. So this is REBOL 3 code. This is how you program REBOL to access the binding, and then you can program cURL through REBOL. It's an extension, so you have to import it. Then you can ask some basic information from it and some help text how you have to use the functions. And I can show you how it is. If I do R3, I get REBOL 3. This is the current alpha version 110 of REBOL 3. And here again, 4.2 is the code for the Linux version. And it also says platform Linux, because this is really the native Linux version of the REBOL library, the REBOL interpreter. But we can just use it on Syllable desktop. So I'm in the REBOL shell now. And if I do that same import command, it's nice to try to cut and paste it. I copy it from the web documentation to the Syllable terminal. But I have to leave out the current directory specifier because it's installed in the system, so you need to find it in the system libraries. Now I have a curl object defined, and I can ask the help
This
from...
is the REBOL prompt, eh?
This is the REBOL
Yes,
shell.
Those two.
Yeah, I can ask the help information from the curl interface, and these are all the commands that are available now from curl. So it's fairly extensive, but curl is a very extensive library, so we need even more in the future. But these are the base commands that you use to program curl from REBOL. And this is halfway corresponding to the curl interface. It's a C interface, so it's fairly straightforward one-to-one. But I made some simplifications to make the interface more REBOL-like. So it's a bit simpler and more compact than the real curl interface. But on the other hand, you don't want to do a lot of manipulations in C because you want to interface to REBOL and then you want to do your programming in REBOL. So the interface is not much changed. I made it a bit more REBOL-like, but basically this maps fairly well to the curl interface. And then we'll see what you have to do to use it. So this is how you import it, what we just did. This is the information. And then here's the first simple example. This is how you read a web page. And it's a bit complicated because in curl you have to open a session. Curl works with sessions, and that makes it more complicated because there's not a single read command for reading a website, because you have to open the session and then read the page in that session and then close the session. So it's a bit more complicated, but it's very powerful, because if you open a session to a server, that's a connection. And we just uploaded a website of one page to our server. But usually a website will be many files. And if you do that with curl, you open a session, so you open one connection to the server, and then you upload all your files in one session. So you have to make the connection only once. And like we saw in the terminal, if you log into an FTP server manually, You have to log in and give your username and password. And that is done in the opening of a session in curl. So if you do it this way, you only have to do it once. So the upload of multiple files is very fast because you don't have to re-log in. So it looks a bit complicated just for reading one page. And I will make it simpler because in REBOL it's normally just one read command, so it's really very simple. But that is a higher level layer in REBOL that I will put over it later. So this is the lower level curl interface, how you program curl directly from REBOL. And if you do it that way, you can make it more efficient. And it needs to be even more complicated than this because I'm doing no error checking in this first example. So if you want to make it really robust, you have to check for errors like this. So then it becomes a little more complicated. And then network operations are never reliable. Always something can go wrong. So if you get an error from a network connection, you have to retry a number of times. So if you program that, it's not programmed in curl because curl is a low-level library, so you have to do the retrying yourself. So this is an example which retries 5 times maximum. So if you want to retry a different number of times, you have to change this 5 or make it a variable. So if you properly do the retrying, the example becomes even more complicated. But it's still, the examples are just in one page, so from REBOL it's really fairly simple. And as I said, I will put a simple REBOL layer over this, but this is a more efficient way to do it. And here are some extra examples for improving the efficiency. This is an example for writing. So this is really what we did when we uploaded our web page. These examples are for reading. You read a web page. And this is an example for writing, where you upload a file through FTP. So this is what you can do to upload one file to the FTP server, exactly what we just did. And you can see that in that FTP URL, just like we did in the terminal this morning, we can give the username and password. Now, and here an example that in one session you can do multiple files. So here we open one session, and in the same session we read 2 pages.
Oh.
Hey, Peter.
Make je laat.
Another visitor. Bit late.
Heb je mij niet horen zeggen?
Nee, ik hoorde je denken.
You have 40 minutes to enjoy Syllable today. En je valt met je neus in de boot, hè?
Oh.
Because we're just reviewing REBOL interfacing with the curl networking library.
Papa.
I wrote a binding from REBOL 3 to the curl network library. That's one of the things we're introducing today.
Oh, that's way too cool for me.
Okay.
I forgot.
Peter,
Je kan beter even blijven zitten, want het is voorbij voor je het weet.
Oh, okay.
Peter gets this very quickly, so when he is seated and he sees this example of downloading 2 web pages, he'll be able to understand it. Even though it has square brackets instead of round ones. Here a curl session is opened and an FTP file is uploaded. And the session is closed again and it's checked for errors. And here one session is open for reading 2 files, reading 2 web pages. And you receive the data in binary format, so you know that the web page is a text file, so you have to convert the binary data to a string value. to get the text. Now we're getting some more complicated examples. This is a nice one because curl is written in C, and with this binding you can call C functions in curl from REBOL, but there are also cases where you want it to go the other way, and that's called a callback. Here we define a REBOL function that is called progress, and when we have opened curl, we tell it where that progress function is. So here we tell curl that we want to use this progress function which is written in REBOL. And then curl from C code.
So the upper stuff is REBOL and
This is all REBOL.
okay. Yeah.
This is all REBOL. But the point is that when we call curl, we go into the C program. And then curl knows how to call a REBOL function from C, from curl. And curl can do that whenever it wants. Now this is a progress function. So curl calls the progress function when it has new information about the status of your transfer. So when you write a download utility, for example, you want a dialog that says we're at 10% of the download and we have half an hour remaining. And you want that information to update during the download. But we're doing the download with curl in C code. But later this year we'll have the REBOL graphical system in Syllable. So we want to make the window in REBOL. So we want REBOL to draw a window with progress information that only curl has. So we define a REBOL function, we give that to curl, and then curl will, during the transfer, it will call the REBOL function when it has new information about the transfer, and then REBOL can update the window that tells you how long you have to wait for the transfer to end. And then such a progress window usually has a button to cancel the transfer if you think it will take too long. So if you have a REBOL window with a cancel button, then normally you return 0 from this progress function. But if you return a different value, 1 for example, curl will know that you want to cancel the transfer. So by defining a progress callback in REBOL that curl calls, you can write the user interface, the window in REBOL, while you can do the network transfer in the curl library in C code. So this is an advanced two-way communication between REBOL and C code. So this example is about a progress callback.
But that is one of the things you wrote, the progress stuff? Or?
These are examples.
Yeah.
These are example programs that I wrote. Now this is even more advanced because this is an example. This is the simple thing. If you ask curl to download a big file, your program will be in curl until it's done. And with a progress callback you can have your own progress window even with a cancel button. But that's all you can do, only the progress function. So if you have a complete graphical program and you want to do all sorts of things, and maybe you want to download more than one file at the same time, you have a problem, because as long as you're in curl, you can't update REBOL, so you can't update your user interface. And you can't do other things that REBOL needs to do if you want to do more than one thing at a time. So the progress callback is a simple way to solve simple cases, but if you want to handle complex cases, you have to do things at the same time. And then you have to use a more complex mode of curl. And in that mode, curl does multiple things at the same time. It can do multiple files at the same time. so it can download multiple files at the same time, or it can download one file and upload another file at the same time. But at the same time, the effect is that curl returns immediately, so you stay in your REBOL code while the transfers aren't done yet. But that means that REBOL gets the control back, so it can do whatever it wants. It can update user interfaces, or it can do other things that it wants to do at the same time. And that's great.
It's like the difference between the responsiveness of the user interface in Linux and Syllable. That in Syllable you try to have the user interface always the highest priority.
That's the direction we're going with this. But the point is, at this time, REBOL is single-threaded. And curl is also single-threaded. And that's a bit primitive, but it makes things more simple and more portable. And Syllable's concept of making user interfaces responsive is to make them multi-threaded. So everything happens at the same time. But in curl and in current REBOL, and REBOL is going to get multitasking, but probably in REBOL 3.1, but REBOL 3.0 is single tasking. And curl is also single tasking. So curl and REBOL are running in one process. And when we saw the web server run on Syllable server, we saw that one REBOL process is two operating system processes. But that's not significant because it's just a help task. And in the newest REBOL 2, it's been optimized to one process. So at this time, REBOL is single process and curl is always single process. En het is also single-threaded.
De tape duurt nog 20 minuten.
Ja.
Dus ik stel voor, want dan hebben we nog 10 minuten, maar dat we dan gewoon stoppen. Want dat,
ja. We'll finish the curl-binding and then I'll take 15 minutes to introduce the new live CD. In Syllable you would program this as threads. But we can't do that in REBOL yet. In the future we'll have threads in REBOL. But at this time it's single-threaded, and curl is always single-threaded. So the way to do things in parallel in curl fits very well with the current REBOL model, which is asynchronicity. You have to do things asynchronously in one thread, in one process. So when you call curl, curl has to do its tasks, but then it has to give the control back to REBOL immediately, or in any case very quickly. And then you're back in REBOL and you can do your REBOL things, but then the problem is that curl isn't done with the transfers. So you get your control back in your REBOL program, but now it's REBOL's responsibility to give the control back to curl fast enough that curl can handle its transfers. So you have to switch between curl and REBOL all the time, very quickly, so that they both get the chance to do their things. And that's called an event loop. If you want to do single-threaded parallelism, you need an event loop. So this is an example of an event loop that is programmed in REBOL. And what it does is, it opens a group. So there are two concepts in curl. There are sessions and there are groups. And so far we didn't need groups. But now we start by opening a group. And in a group you can have multiple files and they're going to be handled at the same time asynchronously. But if you do just one file, you can use it to do it asynchronously together with REBOL tasks. So in this example, we're just handling one file. We're just reading the REBOL front page again, but we're doing it asynchronously. So we're opening a group, and we still need sessions, but we have to add a session to a group. So like before, we're making a session with a read buffer to receive the data. But this time we're also creating a group, and we're adding the session to the group. And in this session we want to read the REBOL front page. And then, once the group and the session are set up, we enter the event loop. And the event loop is this while. And in this while loop, in this event loop, we're calling curl. And the function that we need is the doEvents function, where curl can process its events. And curl will return very quickly. And then we have to check whether the transfers are done. And that's what we're doing with this test. We're testing, we're getting back the number of processes, the number of transfers that are still running. So when the number of running transfers is 0, the remainder of the transfers is 0, we leave the event loop. And as long as there are still running transfers, we remain in the event loop. So first we give curl the chance to do its events. And then curl returns very quickly. And then we give REBOL the chance to do its events. And we do that with the REBOL wait command. And we make it wait for a tenth of a second. So basically this loop runs 10 times each second. So basically 10 times per second we're switching control from REBOL to curl and back. And curl is doing some of its events, and then REBOL is doing some of its events. Because if you do a REBOL wait, it's not really waiting. It waits, but it also looks if there are events to process. But you have to be careful, because it's possible that curl has a transfer that can't wait a tenth of a second. A tenth of a second is a very long time in a computer. So first we ask curl how long we are allowed to wait. And if curl doesn't mind, we wait a tenth of a second. But if curl does mind and returns a smaller timeout, we wait for that smaller timeout. And the timeout is in milliseconds, so I have to divide it by 1000. And to be extra safe, I divide it by 2000. So we ask curl the maximum delay time, and I divide that by 2 to be safe. And then that's the time that we let REBOL allow to process its events. And if curl doesn't mind, we wait for a tenth of a second. So the event loop runs 10 times each second or faster. If curl is in a critical part, then it runs faster because curl says that it can't wait that long. And when all the transfers are done, we leave it, and then we check for the status of the transfer. Because we don't get the error immediately, we have to, because everything is done in parallel, we have to wait until the transfer is done. And then afterwards we have to look up if there was an error. So everything becomes more complicated. And then if there's no error, we have to do the cleanup, we have to close the group. And as before, we have to close the session. First we close the session in the group. Then we close the session, and then we close the group. So everything is more complicated because of all those extra layers. Now, and if everything is successful, we have the data just like before, and we have a binary website that we need to transfer, need to convert to text again. So that's the most complex and advanced example that you can do at this moment. And then there are some simple, more or less standard things like changing the user agent. So normally if you go to a website with Webster, the website knows that you're going there with Webster. And if you do it with curl, then the web server knows that you're accessing it with curl. But the web server can use that to block your access. So if you want to fool the web server, you can say, yeah, but I'm telling you I'm really Microsoft Internet Explorer. And then the web server will give you the data that you want because you're fooling it that you are Microsoft Internet Explorer. And that's what you have to set in the user agent header. With this you can set headers in your request, and you can tell that you are a different browser than you really are. And you can set cookies, because a web...
Can't the server resolve it otherwise?
No, if you tell it I'm Internet Explorer, then the server is none the wiser, because you have to see it in the headers of the request. So you can fool the server. And that's necessary to do web scripting in many cases, because normally you are a human user going to a website with a web browser, but you can automate that with curl. But then the web server can say, yeah, but you're an automated robot, and I only want to give my data to human users.
So what I told you last year about scripting YouTube, it should be done this way.
Yeah, this is the way to do it.
Okay.
And then curl can say, well, if you're going to be difficult, then I can be difficult too, and then I'm going to fool you, and I'm going to tell you that I'm really Internet Explorer by setting the user agent field. And in scripting, the server often expects that the web browser has kept cookies from the server. And if you just do a website read, you're not passing cookies. So if you want to really pretend that you are a web browser, you can pass your own cookie headers. So you can provide cookies in your request, so that the web server will really think that you are a web browser. And that's the way to program. If you have a form on a website with fields that you have to fill in and then click enter, this is the way to automate it. This is the way you can do it automatically, and you don't have to be a human typing in those values by hand.
So name 1 is the name of the form field, and content 1 is
Yeah.
the input.
Yeah, you have different fields in a form, and these are the field names. So this would be a form with fields named name 1 and name 2. And this is the content that you say you have filled into those fields in the form. There's all sorts of stuff you can set that way. And REBOL 3 has an HTTP protocol, but it doesn't support proxies yet. But curl supports proxies in a standard way. So you can use curl to do HTTP requests through a proxy, because REBOL 3 can't do that yet. So with this binding you get proxy support, and you get SSL support. You can't do encrypted HTTP requests yet over HTTPS with the built-in REBOL 3 protocol. So you can do that through curl. And here's all the source code to the binding. Hey Bart, yet another visitor.
I suggest showing the live CD,
Yeah.
because it has 7
Well, that's perfect. When Peter came in, we were dealing with REBOL, and that's what he wants to see. And when Bart comes in, we can show the new live stream. It's excellent, really. So I'm going to clean up all the windows that we have open.
I thought you were going to demonstrate Lisp.
Yeah, REBOL. According to you, REBOL is Lisp.
Yeah, and badly packaged.
Well, in any case, the website that we made and that we uploaded to Syllable server, we uploaded that with REBOL 3. We built the website with REBOL 3, but we also uploaded it with REBOL 3. And REBOL 3 can't do that because it doesn't have FTP. So we uploaded it through my cURL-binding. So that REBOL 3 has FTP through curl on Syllable. And we uploaded it with REBOL 3 through curl on Syllable desktop to Syllable server. So that's what we meant all the time in the last years when we said that we wanted to do integration between Syllable and Linux and REBOL.
That's why we didn't see you for 1 year.
And that's why people didn't believe it, because it's a little bit complicated, but we're now far enough that we can show a lot of what we wanted to do. So this is what we meant all those years by the integration that we wanted to do. And this is just the start of it. But it's really, you can do very useful things with it. That one browser is still hung, so I have to do Control-Alt-Delete now to force the browser to close. But Control-Alt-Delete is an orderly reset of Syllable Desktop. So it has closed off properly now.
Ooh.
So now I'm back in the Start menu, but what I really want is the new Live CD. This is a new Syllable Desktop Live CD. This is a sneak preview on this conference
Yeah.
for all the visitors. Here you are.
Oh, thank you very much.
And we're going to demonstrate it now.
Has it got REBOL on it?
This is
Yeah,
going to be a collection
the
item.
same REBOL 3 and the cURL-binding that we just saw is on this Live CD. And now you see that I planned perfectly because there's only one CD left. So the planning for CDs really wasn't that bad.
This is going to be a collector's item.
Exactly. So now I have one CD left for the demonstration.
Can you get your signature on it?
Yeah. If you have a pen. So I have to reset once again because I have to I have to force this laptop to start from CD. This way. And we know that on this particular laptop we need to disable SMP because otherwise Syllable doesn't work on this laptop.
It's a small tip for people trying out the Live CD that when something doesn't work, just try another boot entry.
Yeah, you can start at the top of the list, and this is Syllable 066, so that is the current stable release, but it's already a year and a half old. But we didn't have a live CD of it yet because we needed to make a new one. So this is really a new live CD, and this start menu is newer than Syllable 066 has. This is really our newest start menu from the development builds, optimized for a live CD. So there are many more options here to do troubleshooting if your hardware doesn't work in the standard configuration. So on this laptop we know that we have to disable SMP. It's quite fast for a live CD. It starts in 40 seconds from a CD on this laptop that's 13 years old, so that's really not bad.
30 seconds, 13?
40 seconds. If you start Syllable from the hard disk, it's less than 20 seconds on this old laptop. Well, there's really not terribly much to see because this is quite similar to the Syllable we've been using for the demonstration all day. But this is a new live CD, so the software versions are new compared to the current live CD. This is the Syllable 066. A few things don't work yet, so I'm going to fix a few more things in the coming weeks and then we'll release it, but most things work, so this is really a sneak preview. This is all the system information. And you can see here, this is the total memory in the machine. So the total height is 192 megabytes on this old laptop. And the blue part is caching, so that's not really needed. So the memory that it's really using is the black part. So that's less than a third of what's in there. So the live CD takes something like 40-45 MB of memory. So you can run the live CD on a 64 megabyte machine.
65?
Yeah. These are all the devices, the hardware in the machine that it recognizes. There are still a few unrecognized hardware pieces left, but not many. The PCI is recognized, the USB controller, the video card is fully supported here, the audio is supported.
How do you mount a USB disk with the live CD?
The network. It is possible that this live CD, that one of the things it doesn't do yet is a USB disk, because I had a problem with it this morning. So I'm not sure it can mount a USB disk, but it can mount other hardware partitions, and it can mount CDs. It's possible that mounting is broken in this live CD preview. I'm not entirely sure, but it recognizes the DVD player and the hard disk, the old floppy drive if your laptop has one, and the USB mouse and the keyboard, serial ports. And the CPU load is really low if you do many things. Here's the easiest way to start the web browser, through the welcome documentation from the desktop. On this live CD you currently have to double click to open. And the web browser is our biggest program, so from the CD it takes a few seconds. That's the welcome document. We don't have a connection